Hello Matrix. Today's lesson is on finding the coordinates of the center and the radius of a circle given the equation. We're going to do 4 examples together, and these examples can also be followed on page 291 of your textbook. Example 5a, x squared plus y squared equals 16. Now, before you can determine the center, you have to make sure that the equation is in its standard form. All right, and that means x squared plus y squared on one side and a constant on the right-hand side, or alternatively a bracket x minus or plus a constant all squared plus y minus or plus a constant all squared. And if that's not the case, then you have to reorder the equation so that you can find. It's almost similar to when you're dealing with a parabola and you asked for the turning point. You have to make sure that you put the parabola in the form y equals a into x minus p all squared plus q. All right, so here we can actually determine the circle center straight away, because we could rewrite this. You don't have to, but we could rewrite this as follows, and it would mean the same thing. All right, so the question, by the way, here is for all of these examples is to determine the center's coordinates as well as the length of the radius. Okay, so remember that the general form of the equation is x minus a all squared plus y minus b all squared is equal to r squared. So we need to put it into that format. All right, so if we write it in this format, we can clearly see that the center is the origin in this case, and the radius is equal to the square root of 16, which I have shown here as 4 squared, and therefore the radius then is equal to 4 units. Example B, x minus 4 all squared plus y plus 3 all squared is equal to 18. Now again, the equation is already in standard form here, so there's no manipulation that you need to do, and we can go straight to saying that the center, in this case it's not the origin, and remember you need to change the signs, okay? Because of the fact that there's a negative in the standard form, it means that whatever sign is there, it actually is the opposite when it comes to determining what the coordinates of the center of the circle are. So in this case, it's positive 4 and negative 3. The radius is always equal to the square root of the right-hand side. So the square root of 18 actually simplifies to 3 root 2. And you can use your calculator to help you do that. All right, with this one, you can see that it's in a completely different format. So effectively what's happened here is the original standard form of the equation, where it was x minus a all squared plus y minus b all squared, has effectively been multiplied out. So we need to factorize it again so that we can find the coordinates of the center. And the way that you do that is by completing the square, but we have to do it twice. We've got to do it first for the x, and then we've got to do it for the y. So it might help you to do it as follows. You're going to reorder the equation so that you put your x terms together first, and then leave a space here. That's where we're going to put that third term in. All right, and then we have the positive y squared plus the 5y, and again leave a space here for that third term, and the constant always goes to the right-hand side, which is already the case here. All right, so you might just need a quick crash course on how to complete the square. So once you've put them in standard form, so we've got the squared, x squared term, then the x term, then the y squared term, and then the y term, we are going to complete the square by halving the coefficients of x. So 6 halved is 3, and then squaring it, so we get positive 9. All right, and then that positive 9 goes in here, but we must also add 9 to the right-hand side to keep the equation balanced. All right, and then if we look at the y values, half of 5 is 5 over 2, and if we then square 5 over 2, we get 25 over 4, and we also add that to the right-hand side. Now we can factorize this trinomial and the second trinomial. They will be two perfect squares. So the first one becomes x minus 3 all squared, and then the y bracket becomes y plus 5 over 2 all squared. And then on the right hand side you add the 4, the 9 and the 25 over 4 to get 77 over 4. Alright, so now it's in standard form. We can say that the center of the circle is 3 and negative 5 over 2, and the radius is equal to the square root of 77 over 4, which simplifies to root 77 over 2. Remember, it must always be positive because it's a radius, it's a distance. Example D, x squared plus 2x plus y squared minus 10y plus 1 equals 0. Right, so we're going to do a similar thing here. We're going to collect the x terms on their own and leave a space for that third term that makes it a perfect square. And one extra thing that we're going to do in this one is take over the positive 1 because it's a constant to the right hand side to get negative 1. Alright, and so now we can fill in the extra terms. And if we look at the 2, the coefficient of x, 2 divided by 2 or 2 halved is 1, and 1 squared is 1. So we're going to add 1 to this term, and therefore we add 1 on the right hand side as well. Then with the y values, half of 10 is 5, and 5 squared is 25. So we're adding 25 there, and we're adding 25 on the right hand side. So you can see already on the right hand side the two ones are going to cancel, and we're actually just going to be left with positive 25 on the right hand side. You can't get a negative there because it's a distance, so if you get a negative then you've most likely done something wrong. Alright, and then once again we're going to factorize that trinomial and we're going to factorize that trinomial. Alright, so this becomes x plus 1 all squared, and the y trinomial becomes y minus 5 all squared equals 25. So that means that the center is negative 1 and positive 5, and the radius is very easy to work out here because it's a perfect square already. So the radius is the square root of 25, which is 5 units. Alright, just one thing to remember here, please. You collect the variables on one side, and any constants go to the right hand side, which you then add or subtract to whatever is the third term that you've created, in my case the red and the green. Right, that comes to the end of our extremely long lesson for today, and your classwork/homework is given there, exercise 7.3 on page 292. Question A, the left hand column. So for those who don't know which the left is, it's the one that has 1, 3, 5, 7, 9, 11, 13. And then you also need to do B, C, and D, 1 and 2 for B, C, and D. I will post the memo after school today.